Hello all, good evening. In today's webinar, we are going to discuss about orchestrating workflows. Orchestrating is nothing but you want a certain task to run one after another in a sequence. Like you want to collect data, let's say that is task one. Only when the data is collected in particular storage or in particular table, then you want to run task 2, where you read that data and do some operations on it, and then you load that data. That is task 3, load that data to a different table or to a different storage. And you want orchestrate your workflows in this way only. And further, you want this workflow to run on certain schedule, daily at particular time or once in an hour. And doing these things is there are certain tools which allows you to do that, which allows you to orchestrate your and schedule your workflows. You want your tasks to be coordinated in right order, in right time, with the right dependencies. And once you set this workflow, once you orchestrate your workflow, and there onwards, without your intervention, they have to be up and running in the right time, in the right flow. There are different tools and techniques which helps you to achieve this orchestration. Now we are going to talk about the thing in Databricks. What services or what tools Databricks has to support that orchestration. And also we will do some hands-on. We will run some code, generate data, and we will see how this orchestration work here in the Databricks. I'll go to this place, jobs and pipelines. See, here you can create a ingestion pipeline where you can ingest data from apps, databases, and file sources. Whenever data arrives in the data sources, automatically they will be ingested. And then you have ETL pipelines, which will extract, transform, and load using SQL and Python. You can do this, extracting data from multiple sources or from a single source automatically without you triggering the pipeline. And then you want to do some transform on the data and then load it to a different storage or to the same Databricks in a different table. That is ETL pipeline. And then if you want to orchestrate any other kind apart from ingestion pipeline or ETL pipeline, you can create jobs, orchestrate notebooks, pipelines, queries, and more. Okay, ingestion pipelines and ETL pipelines are also kind of jobs. You don't want to go with specific template, then you can customize your job on your own. And to observe this orchestration of workflow, we will create a sample ETL pipeline. Right, for that we will take a use case. We will take our data source as some IoT sensor data. Yeah, and this IoT sensor data will be generated every minute. We will simulate some synthetic data. And this data comes into something called as delta live tables. See, there is a difference between normal tables which you create on Databricks and these delta live tables. These are automatically ingested when data arrives in the source, like streaming data coming from Kafka or any other data source. Whenever data arrives at particular location, automatically data live tables will take that data. And here you can create some autoloader which keep on observing certain location. Here IoT sensor data, where it comes, you will create some location in Databricks. It could be DBFS, Databricks file system, or S3 bucket or Azure blob, anything you can attach as a location. Let us say when data arrives in a certain location, automatically that data should be loaded into the live table. And here data comes as a file format in JSON format because it's event data. I'm taking example of a sensor data. It comes in key value pairs, and where it comes in any one of these locations, whether it is Databricks managed location, storage, or external storage you can attach like AWS S3 blob or GCS you can attach, and some device is writing data into these locations. You will create a delta live table. Whenever there is a new data in this location, this auto loader will write the data into the delta live tables. And here we will call this table as bronze table. And Databricks is very popular for this architecture, bronze, silver, and gold. They propose this architecture and they recommend to create your ETL to save your data in layers like bronze, silver, and gold. Bronze is nothing but data in its raw format. It might come from single source or multiple sources. It is in raw format. And sorry, whatever cleaning you want to apply, you will clean, and that data you can call as a silver. And if there are any other tasks like aggregating the data, like answering the business questions, these kind of data finally brings more value, and that is what the quality of data expected by the end user. And in this case, who are end users? A data analyst or a data scientist. They consume this data. Data analysts, they'll build dashboards. Data scientists, they'll build forecasting prediction models. In this case, I'm saying sensor data. Data scientists are involved in creating predictions and sometimes forecasting the numbers. They'll make use of this data which is in gold layer. And they have certain requirements. And you'll ensure that once data is of right quality, as expected by data analysts and data scientists, you'll put it in gold layer. We will follow the same. We will create a ETL pipeline. And yeah, we will build it here. Okay. Now let us get into this use case. First, I want to recap once again about the Databricks system, that is Unity Catalog, not system, storage. Right, again in latest Databricks, they have made few changes. You cannot see the Databricks file system directly. You don't have access to the DBFS root. Instead, what you have is Unity Catalog. Anyway, you have by default workspace, and there you have something called default schema. Here you can create tables. But what you don't have is a default file system. That means if I want to save a JSON file or a text file or an image file directly in its raw format, I don't have a default file system. In earlier Databricks Community Edition, they used to have this DBFS system root. They used to provide it. Now you can directly create table here. However, you want a raw file system. In our scenario, we want a raw file system because IoT data comes into this raw file system, Databricks file system. And from there, it will be written into the bronze table, and from there to silver, and from there to gold. So, if you want a file system which can save your data in raw format, then you have to create your own catalog and volume in it. Or in default catalog also, you can create your own volume. And how to create that? Click on this plus icon, go to catalog in your Databricks account. Click on this plus icon. Here you can create an external location. Suppose you want to add S3 bucket, Azure blob, these kind of object stores. And you can create a credentials, especially when you are connecting with external location. With a credential, you can connect, and you can create a catalog of your own. Catalog name IoT demo. Create. Yeah, configure catalog. This thing you can keep default for now. Let's go to next page. Metadata also. Just save it without metadata keys. Yeah, IoT demo. It has a default schema. And here you can add volume. See, default schema, go to create. You can create a volume. See, this is IoT data volume. It's a managed volume, meaning it is managed internal to Databricks. If you want to add external locations like other cloud storages, you can choose this and create volume there. Create. In this way, you can create a catalog for your own. This is catalog, and what you created is a volume. And further, you can also create a table. See, you have option to create. Go to schema, create. You can create table or a model if you want to implement machine learning or AI. Okay, now let us go back to our workspace. That is a place where you can see all your notebooks. I already created this notebook called Orchestrate Pipelines Demo. See, here I already tested this. I'll explain the workflow once again. Here we are generating synthetic IoT data, which goes into volume. Just now we created a volume. In what format? In JSON format. And here we will create one table called bronze table. And whenever or as soon as data comes into this volume in JSON format, it has to write into this table, bronze table. And here we use something called autoloader, which will automatically load data into the bronze table. From bronze table, we will make some read some data and make some transformations, changes. We will clean the data, standardizing, cleaning, like handling null values, ensuring that all the rows are of same valid data types, not same, valid data types. These kind of cleaning we will do, and we will call it as silver table. And then gold table. We will check some business rules. We will aggregate data, summarize data. Sometimes if you have been asked to add new columns, we will do that. And finally, we will put the data into the gold. And this is the place where end users will make use of data. Now, what we are doing here is ETL, extract, transform, load. We are extracting from this volume initially into one place we call bronze table, and then we do some cleaning and apply some other transformations, eventually load it into silver and gold tables. You are extracting, transforming, again loading into a different table, or sometimes it could be a different location external to Databricks. Okay, now I want to orchestrate this workflow. Like only when data comes into this volume, then only auto loader has to get the data. It has to write into the bronze table. After that task is done, task 2, cleaning. Cleaning has to be done. This is task 1. This is task 2. After cleaning is done, data should be there in silver. After task 3, applying some business rules, doing some aggregations, we are writing in gold layer. That is task 3. We want to orchestrate this workflow so that it has to run in this order only. And further, you can schedule it to run at right time. You know that every hour IoT data will be there, or data will be continuously coming. Every hour you want to load it into the bronze table. So you can create schedule for every 1 hour. Right? And you want to automate this orchestration, and at the same time, by adding the schedule, actually, you'll automate it. So these things we will do hands-on. For that, first I'm ensuring that uh, in demo.iot, I already created this catalog. Just now I have shown you how to create a catalog, right? Duplicate. You can just go to catalog, click on this and create a catalog. I created a catalog called demo and I expand it out. There is default schema, information schema. These two anyway, they'll come when you create a catalog. And I created one more schema called IoT. And there are around 6 tables. Bronze data, bronze, because I tried and tested things before the class. I created these many tables. I just want to make use of the same catalog, same schema. So I'm ensuring that I don't want those tables with same names, gold, silver, and bronze. So I'm dropping those table if exist. See, I didn't connected the cluster. Anyways, cluster will be connected. I'm using serverless cluster only connected. And then it is executing. Okay, you can see that it is done. Dropped all the 3 tables. And to verify the same, I'm saying show tables. And I don't want the previous outputs to come in. So I'll go to run, let it complete. Okay, meanwhile, I'll go to run, clear all cell outputs. which will clear this output also. So before that, we will check once. Bronze data, readings, silver readings cleaned. These tables are there. The tables which we have removed, gold, silver, bronze, you can see they are not in the list. We'll go to run, clear the all cell outputs, confirm. And also I'm ensuring that I don't want this volume. In volumes demo, I'll take you to Explorer. There is one volume you see called sensor data. And within the sensor data, there is raw folder. And you can see data over there. And let me go back. And schemas is also there. Bronze schema. I don't want this. I'm also deleting them. But this, I cannot choose Python, maybe Scala, Markdown. Let's see. Run. Yes, it's working with as a Python cell. Why it's returning as false? Let us see. Okay, if there is a file, we are saying recurse. So until it becomes false, it will complete it. It will remove the volume. And we are checking the same. No volumes. Right where in this location, demo IoT sensor data and demo catalog and IoT schema. We created a sensor data with that name volume. No files. Now it is good to go. And again, we are cross verifying. No tables left. No volume is empty. Same thing again using SQL. That's it. So I'm not running these two. Now again, yeah, for demo purpose, I'm creating this volume sensor data. Now let me refresh. Even after refresh, it's not updated. Volume sensor data. See, but you don't see any files, right? Only schemas folder is there. Now what I'm saying, create volume if not exist. It's already there. We didn't deleted the volume. We only deleted the files inside the volume. But still we are saying create volume if not exist. It will create if it is not there. If it is there, it uses it. Run it. I repeat again, volume is the place where you can save your files in raw format. It's not, it will not try to arrange it in a tabular form. And sensor data is our volume name. And then we are sending some data, synthetic data, into that volume in a folder called raw. For this, to do this task, I'm importing JSON. You know, JSON, if you want to read or write JSON values, you have to import this. And here I want to generate data and also I want to write the data in JSON format. Since I want to generate some synthetic data, I need to select some random values. Random is the package which helps you to do that. And time, date, time, which helps you to like generate time in Unix timestamp and date time to associate date and all. And from PySpark, here we are using PySpark code. We are importing functions. And you can see, anyway, we know about this now. This is the path we are creating. Already up to here, sensor data is there, volume is there. There I'm saying that use a folder raw. And I'm ensuring that if there is any raw folder, it will be removed. Before that, just I'm ensuring I don't want to mix old data and new data. Anyway, we cleaned up, but still in the code also, one more step I'm taking. I don't want this raw folder if it is already there. So I'm removing it. Okay, and then number of devices 20, and we are simulating 1000 rows for each device. And you can see the start time. We are creating an epoch time. That means everything will be mixed. Hours, minutes, seconds together. You'll get one sum. We are creating that time, and we are taking off uh, this value, meaning we are creating a time that is previous 24 hours previous of the current timestamp. Just I want my sensor data to be a 1 day old. That is why I'm giving the start time, not exactly as current time. I'm taking off few seconds or a value from it, which is means this value takes back 24 hours from the current time, and that timestamp we are choosing, and we are generating data. Yeah, as you can see, this device ID, it will generate a 2-digit device ID, like device some D001002. Say we are saying add 2 zeros, and then a 2-digit padded ID will be generated, and we are generating some random synthetic temperature values. And I'm ensuring that this temperature value should be around 22. So I have given my distribution as 22. Around all the rows, temperature mean has to be 22, entire data set. And other rows, I mean, I don't want exact every row to be 22, plus or minus 2 degrees. But overall mean should be something around 22, and we are rounding these random values to 2 decimals. And that's what it will do, round function. You can see it creates random value using normal variate 22, which ensures that mean will be 22, but the values it will generate with plus or minus 2 degrees, like 24 degrees or 20 degrees, some values as 22 degrees. And that's how we are generating synthetic data. And then TS, which will give some timestamp, start time. And we don't want this to be very like it's a synthetic data, but we don't want to make it look like a synthetic data. So from the start time, we are incrementing it. First of all, we are adding data for every 1 minute from the start time. And if you see this random, we are adding a jitter plus or minus 5. That means plus or minus 5 seconds delay to make it more real time, to look like a real time. And all this data will be ingested into a data frame, and that will be written as JSON data into volume raw, which is this one. If this folder is already there, it will make use of it. If it is not there, it will create and write all this data in JSON format here. Let us run this. Okay, row 20,000 rows. Let us go and check. Refresh. Sensor data. Go to database, refresh, and then go to volume, sensor data. You see the raw folder here and all the data. That rows, 20,000 rows, are written in file format, in JSON file format. and these many files came in. Okay, up to this part is fine. We generated synthetic data. It is available in volume. Next, I want to create a bronze layer, which takes this data into raw data into tabular form. That part I'm not going to run here. That bronze, silver, and gold tables, I want to run in pipeline. This, since I don't have a real device, etc., I'm using this notebook just to ingest data into that volume. Now I want to create a workflow whenever a new file comes here that will be automatically loaded into the bronze layer and then be cleaned, available in silver layer. From silver layer, some business rules, values, aggregates will be done and saved in gold layer. That part now I want to orchestrate this data to bronze, bronze to silver, silver to gold. I don't want to run this in a regular notebook. I want to run it as, orchestrate it as a pipeline, right? We will write this in pipeline. Now go to jobs and pipelines. Ingestion pipeline, just you are collecting data. Then ingestion pipeline, ETL pipeline, you extract, transform, and load. In our case, we want to create ETL pipeline. Create, click on it, it will take you to this place. Do you want to start sample code in SQL or Python? It will provide you some template, or you want to go with an empty file. I'm going with an empty file. And in which folder you want to create this pipeline? Workspace, users, and then the account name, mail ID which you use to create Databricks account. I'll go with the same folder path. And what language you want to use? I'll go with Python. Python, PySpark, if these kind of languages you want to use, select Python. If you want to SQL, use SQL, then SQL. I'm going with Python. Select. See, a new pipeline got created. Orchestration or orchestrate workflow demo pipeline. And since we created ETL, we chose an ETL, you can see my transformation.py, a blank file came in here. I'll duplicate this tab, go to pipelines. I'll open the most recent pipeline, which I tried and tested. Orchestrate workflow demo, this one. Development only. Jobs and pipelines. Okay, edit pipeline. Let's go here. Okay, go here, workspace. You can see my transformations.py. Okay, this is the same pipeline. Orchestrate workflow demo, my bad. Let me go back. Jobs and pipelines. The recent pipeline, let me check date. I opened it before the class, this one. Just give me a minute, please. I'll try to locate it. Okay, this is the file, yes. And here I'll click on edit pipeline because I want to copy paste the code. I want to view the code, that ETL code, transformation, my transformation.py. See, I'll copy this and come back here, close this and this as well. Now this is the place where I created a table and the blank Python file is there. I'll copy and paste the code here. And what is happening here, I'm creating a table called DLT table, meaning Delta Live Table. These Delta Live tables will be active, will accept the data as data comes from the stream. To add new rows as the new data comes in. You can also call them as streaming table. You can keep on adding data into this Delta Live tables, right, directly from the stream to the DLT tables. So we are importing DLT. We want to create a Delta Live table, and then some PySpark SQL importing functions, and we have set our data path. And we know this is the path where data is coming. Again, here there is a raw folder. Into that raw folder, data is coming. Okay, now bronze. I'm creating a table with the name bronze, and you can also add a comment to your table, and you can see that. And here the data is having only device ID, temperature, and then the TS. Three attributes. With that, we are creating a schema and saying spark.read stream, and which reads data, right? And it returns to the source, which is nothing but this bronze table. So now by the end of this task, bronze is the task ID. You will get all the raw data in the bronze table. Table name is also bronze. It's a DLT table. So I'm saying at the rate DLT.table. Whatever new data comes in this location, in this data path, you can create one more folder raw, or you say every day or every hour a new folder will be coming. You want to write all the data in the folder, then you can give only the volume name. No, you want to be specific about the entire path, you can give the folder name also. Here I'm leaving it like that. Data comes into the bronze layer, and then the next thing is silver layer. We are creating a table with the name silver, and we are adding a comment here. It will validate typed IoT readings. So what cleaning we are doing here, we are checking that temperature range should be between -40 to 60. That is, you can say one business rule. If temperature is beyond -40 or above 60, below -40 or above 60, we don't want that temperature range. Anyways, in synthetic data, we are sending taking care that the data should be somewhere between around 22. But anyways, in to make it close to production scenarios, and this data is having only three attributes, and the measurement is only temperature. So I am taking care that temperature should be between this range. If it is not in this range, I don't want those values. I'll drop it. Then DLT table should expect this column. It should not be null. Timestamp should not be null. If timestamp is not there for some reason, for the JSON data that is available in volume, it will not accept. And these two rules we are applying. And also, we are converting epoch to timestamp. That means the one single put together timestamp, we are separating it. See what we are doing? From bronze layer, we are first checking the data. We are validating the data. After validating the data, I am taking event TS, which is a epoch timestamp, which is not very human readable one, transforming that to a timestamp which has hour, minute, and second segments. And also we are creating a minute bucket, like 1 minute slot, and there we are like rounding off the time. We don't want every second value, so we are rounding timestamp to the that minute. In that minute, creating a minute bucket and rounding off the timestamp. So those are the things we are doing in silver layer. And then gold, we are creating a table with name gold, and this is the comment of that table. A comment is like a tag you are attaching, like a name. A comment is some kind of name, you can say, tag attached to the table. And what we are doing here, we are from the silver event TS, which we converted epoch time to proper time, UTC time. There we are selecting, grouping the values by device ID, first thing. And then we are aggregating day wise. You can see we are rounding and calculating average of temperature day wise, daily averages of each device ID. And that is gold layer, final layer. Now I want to orchestrate this pipeline. So I have given this code in pipeline. And whenever you create a DLT pipeline, they'll not run in your normal notebook. They'll run in pipeline only, pipeline notebooks, because they are live tables. They're monitoring for changes. Okay. Then I'll go to performance or tables, transformations. Yeah, here it is. Sorry. I'm searching for this section. Dry run, which will test your code. If you are good at dry run, if it is showing the green segment in each of the phase, I have 3 tasks here. Bronze task. So this is how you create bronze task, silver task, gold task. 3 are there. Just preparing a graph, validating your workflow, and you can see it is success. And you see bronze is streaming table. Silver is also streaming table. That means when changes happens into the volume, the new data will be written into this streaming table, which is nothing but delta live table. Silver table also, if data comes into the bronze, it is also DLT table. It depends upon the bronze table. It has to get and validate the data and clean the data. And gold layer is materialized view. What I am doing, I am creating daily averages. Materialized view is some type of physical table only. The result of this SQL statement will be saved as physical table when you create a materialized view. They are not temporary tables. I'm creating gold table as materialized view. Now, yeah, it got passed in dry run. Now let us run it. Run, run pipeline. You can see the run details here. More detailed run details. Bronze collects data. Silver will do some cleaning. Gold, it has to aggregate. Daily average, it has to count. It is completed, right? Now the development part. Now what we are doing is development part. Now I want to make it run automatically without my intervention. I don't want to go and run pipeline every time. You can create a schedule. Your schedule is like once in a day or twice for every alternate day or 3 days or once in a week. You can select, or you want to customize your schedule. Go to advanced tab and create a cron expression here. Anyway, this is for demo purpose. I'm not setting any schedule. And you can see the run is complete. I'll go to the notebook, which is not pipeline notebook, regular notebook. There I am checking the gold table. Demo iot.gold. I'm counting the number of rows. If it was not able to get, that means your pipeline has failed. If there are rows in gold table, then a pipeline is success. Demo.iot gold table is not there. Just run it once again. Okay, there is some syntax. It is uh, asking to replace. Anyway, accept and run. Run it. Why it is giving this? The table or view demo IoT silver are not found. And here I am using the same. Okay, let me run this once again, which sends data. And then my transform, run this pipeline. And here in this tab, I'll go to catalog, see demo, and in demo I have schema IoT, and there are 3 tables. Refresh. Still 3 tables. Okay, let's wait. See, you can check the table metrics also here, or the problem would be I am using a different schema now, demo IoT sensor data. Okay, refresh. demo, IoT tables. Come back. Anyway, you can see the pipeline is success. The only thing is it would write data when you add a schedule, right? You can try with the schedule. Okay, that is about orchestrating workflows case. Thank you.